The person who invented the laser is really a genius. A thin monochromatic light can illuminate hundreds or thousands of meters, and it also has high energy. So what exactly is its principle? Laser is an acronym for light amplification by stimulated emission of radiation, which was discovered by Einstein around 1916. First of all, we must know that matter is composed of atoms. The center of the atom is the nucleus, and the outside of the nucleus is surrounded by electrons in fixed orbits. This is the Bohr model of the atom. Okay, understood. Let's take the Bohr model of the hydrogen atom as an example, because it only has one electron. Under normal circumstances, electrons are in the innermost orbit, which is the lowest energy and most stable state of the electron. We can define this orbit as zero level, but electrons can also have multiple discrete energy levels at the same time. We use 1,1 and 1,2 to represent the orbits. When an electron absorbs an energy equal to the energy level difference, the electron will jump to a higher orbit, which is called stimulated absorption. But the electron is unstable at the higher orbit. In a short time, the electron will jump to a lower orbit and emit a photon. This is called spontaneous emission. Stimulated emission of radiation occurs when a photon is absorbed by an electron in a higher orbit, and then another photon is emitted in a short time. The photon produced then has the same frequency, polarization, and phase as the first photon. Got this? Looking at the application in lasers, lasers have a resonant cavity and an excitation medium, which can be a gas, liquid, or solid. There are two mirrors. One is a fully reflective mirror, and the other is a semi-transparent mirror, and there is a light pump surrounding the cavity. It inputs light energy into the excitation medium of the laser, exciting the atoms to a high-energy excited state. When an electron returns from an excited state to a low-energy excited state, once the initial photon is emitted, if there are atoms in other excited states, stimulated emission will be triggered, and the photon will be reflected back and forth in the optical cavity. These reflected photons will trigger more stimulated emission, forming a chain reaction of photons, generating more photons. This process is called light amplification. Big. Some of the photons exit through the semi-mirror, creating a highly focused, coherent, monochromatic, and directional beam. Although different types of lasers work in different ways, their basic principles are largely the same. Lasers have unique properties that make them widely used in many fields. Because laser photons have high energy density and focus and can carry a large amount of energy, they have good application prospects in the military field. Because the speed of light is the fastest speed in the world after all, the only martial arts in the world is fast, like comment, share, and follow.